So here what we're going to do is we're going to start graphing those so-called variants of sine of x. Namely, we're going to graph y equals a times sine of x. And of course, a here has to be non-zero. And here, all that's going to happen is we're going to multiply each y value by a, whatever a is. That's what's actually going to happen. In other words, we're going to end up either vertically stretching or compressing the graph of sine of x. We could focus on all possible x values, but again, for time consideration, we only have to look at the interval from 0 to 2 pi. Mostly because what's going to happen here is you're not messing with the input. That is, you're not changing it at all. It's just x. So because of that, the period is not going to change. Hence, we could just focus on any interval of length 2 pi. And just like in the first graph we drew today, in the previous video that is, we can look at the interval from 0 to 2 pi and just focus on these specific x values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And as before, we end up obtaining these sine values here. So now, what I'm doing here is I'm going to take a to be 4, and we're going to look at 4 times sine of x. And basically what's going to happen is we're going to end up multiplying all the y values by 4. So for these, at 0, well, 4 times 0 is still 0. At pi over 2, we have 1. So we're going to get 4 times 1, which of course is 4. At pi, sine of x, sine of pi is 0. So we get 4 times 0 is still 0. Here we have negative 4. And again, at 2 pi, we have sine of 2 pi is 0. So we still get 0. Okay, so with this here, let's actually graph this function. So I'm going to scroll down as I just did. And now, let's see if I can do this. I'm going to try graphing this. And naturally, you can get a better graph, of course, if you use something like Desmos or GeoGebra, one of those. So we have 0, right? We have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so again, we're going to have 4. That's what the max is, and here it's going to be negative 4. Okay, so let's graph it. So at pi over 2, we get 4. 0, we get 0. Pi, we still get 0. 3 pi over 2, we get negative 4. 2 pi, we get 0. So let me see if I can graph this. Connecting the dots, so to say. Okay. Like so. Good. Okay. Okay, so this is what 4 times sine of x looks like. And if we wanted to know what the original sine of x looks like, let's say this was 1 and negative 1. Let me use a different color here. So we're going to have 0, pi over 2, we get 1. Pi, we get 0. 3 pi over 2, it's going to look kind of funny looking, but that's okay, I guess. And we get this. Okay, so hopefully you can see that, yeah, we vertically stretched the graph a bit. Okay, so that's what happens here. And just like before, if we wanted to know what's happening outside the interval 0 to 2 pi, in other words, if we want to know what's happening on the entire domain, which is all real numbers, we just continue the pattern, so to say. That's all we do. In other words, the cycle, right? This is one cycle of our function. Okay? One cycle is completed in this interval from 0 to 2 pi because it's 2 pi periodic. So the pattern will just repeat. We keep on drawing the cycle, so to say. So here what I'm going to do is draw 4 times sine of x on the entire real line. And just for comparison, I also drew, as you can see in green, sine of x. Let me just actually label that. Y equals just sine of x. Okay. And again, this is what I was trying to say. The pattern keeps on repeating, right? As you can see, right? As you can see, the pattern, the cycle, just keeps on repeating. Okay, that's what I'm trying to show here. Hopefully I'm being successful. Well, now let's draw 4 times sine of x. Let me just label what happens here. It's not the scale, I understand that, but that's okay. So at 0, remember we get 0. Pi over 2, we have 4. Pi, we still have 0. 3 pi over 2, we have -4. 2 pi, we have 0. Okay, so now let's draw it. Okay. That's good. All right. And again, it just repeats, okay? That's what's happening here. It's just going to repeat. But again, you can hopefully see that 4, y equals 4 times sine of x, right? Vertically, we're stretching by 4. We're multiplying all the y values, that is, by 4. That's what we're doing here. Let's go on to another example. So here we're going to have negative sine of x. So in this case, our capital A is -1. Now here we're just going to graph negative sine of x. So based on what we already know, we should expect that this is just going to be a reflection about the x-axis. And that is the case. Okay, so let's calculate now. So we have our most important x values, as you can see over here. Here we have sine of those. So for negative sine of those, we just basically are going to negate. That is, we multiply by -1. Well, negative 0 is just 0. -1 we get here. Here we get 0 again. -1. You have a double negative, that becomes a positive. -0 again is 0. So this is what we get here. Okay, so let's actually graph it now. So I'm going to graph it here. Okay, so as before, we have our x-axis, right, and our y-axis, like so. Here's 0. Again, we're focusing just on the interval from 0 to 2 pi, because since we're not manipulating the input x at all, right? We're not negating x, we're negating the outside, for instance. That tells us the period is not going to change. Okay? So let's do it. So at 0, again, we still get 0. At pi over 2, we're not going to get 1, we get -1. Pi, we still get 0. 3 pi over 2, we get 1, about there. 2 pi, we get 0. So graphing it, we're going to have something like this. So that's what y equals negative sine of x will look like in this interval from 0 to 2 pi. So here I just drew y equals negative sine of x on the interval from 0 to 2 pi. And if we want to draw it, that is, extend the graph to the whole real line, again, we just basically keep on going. The cycle repeats. It's kind of hard to see from the way I drew it what's going to happen to the right of 2 pi. But hopefully you can see the pattern that if we went pi over 2 units to the right, you would be down at -1. Over here, what's going to happen is you're going to go up to get 1 at -pi over 2. You're going to come down to 0 at -pi, and basically the pattern keeps on repeating. That's all. So that's what's going to happen. The pattern keeps on repeating. So this is what y equals negative sine of x is going to look like.